We have a particular question that is asking about the revenue of a startup business. So that is our y-axis over here, and that's in hundreds of units. And then the t-axis, or our x-axis, this one over here is in weeks. So we've got those two things. And the question itself is asking, when did the business break even? So I've already highlighted it here. It's going to be at when the y-axis is equal to 0. You're bringing in $0 now. So you're not spending money to start the business, but now you're saying it's $0. You've broken even. So really easily and quickly for this one, this question here is just going to be t is equal to 1 week. Okay, now the next one here is asking us to determine the revenue equation, and we're also given a hint. The hint is that it's going to be in the form of y is equal to ln b of t. So what we're going to have to do is look at this graph here and get some key points. So it's a non-calc question. We're going to have to kind of extract the key points from here. So we've got this point here, and that is point 2 and 1 across. And then we've got another point here, let's say, which is point 4 and also 2 across. And we've also got the original point that we've got down below. So let's put it over here so we can figure out what's going on. So we've got point 1 and 0. We also got point 2 and 1. And we also have point 4 and 2. So let's substitute that in. Let's substitute in the first one. So we say that 0 is equal to ln, not sure what b is equal to, but it's equal to 1 there. So if we have a look at our equation here, the formula sheet, if we've got something along the lines of b to the power of x is equal to y, then what we can say is if we take the log of that, then we've got log, right? So ln of base b to the power of y here is going to be equal to that value at the top. Okay, so just double checking that. So that I guess we can flip it back the other way. In this case, we can say that we've got b, all right, b to the power of the power of 0 in this case is going to be equal to 1. I've accidentally just messed up my x's and y's here. So let's put that y and an x there. Cool. And then what we can then do is say, well, it doesn't really tell us anything about b because anything to the power of 0 is equal to 1. So even if we have 30 to the power of 0, that is still equal to 1. So what we can do is use another value. Maybe let's substitute in when x is equal to 2. So if we've got ln, don't know what b is, we substitute in that value of 2, and that's all equal to 1. Now, what we can do is flip it across so that we have b to the power of 1 is equal to 2. Okay, so now we can solve for b. We can say that b is equal to 2, and that is our final equation. Let's check the next one just to make sure that it's correct, right? Let's substitute when we've got x is equal to 4 and y is equal to 2. So 2 is equal to ln, and let's, does that work for b there? Let's find out. So let's flip it across so that b's down the bottom, that 4 is on the outside, and that 2 becomes here, and that still works, right? If we have 2 squared, that's equal to 4. And therefore, we have found the equation. The final equation for revenue, y is equal to ln base 2 to the power of t. And that's it. That's your marks. So I guess it's a bit difficult to do the swap and also not substitute in the first value there. Perfect. So let's go on to part C. So determine, it's a bit of a different question here, but it's determine x given that we've got this equation here. So normally we'd have a calculator and it would be great. However, we have to solve this for ourselves. So let's take that log of base x to 16 is equal to the minus 4. Now, we're going to flip it around. So remember, this guy is the base, and then x to the power of, it's the one on the right-hand side, is equal to 16. So that's one mark there. But now, what does that minus 4 for indices mean? Well, what that means is that you can flip it like this. Okay? So I guess that works. And then what we can do is we can raise everything to the power of -1. So I'm going to start it like this just to solve for x here. I'm going to raise everything to the power of -1 and this guy here to the power of -1. So just remember, if you have b to the -1, that's equal to 1 divided by b. Okay, so what that means is x becomes 4 and 16 becomes the -1 there. So I guess, does that make sense, right? Like if I've got an equation 2 is equal to 2, and I raise both sides to the power of -1, does 1/2 still equal to 1/2? Yes, it does. So that's why we can do this, this little step here. Okay, so that makes life a lot easier. Now we can just, I guess, raise everything to the power of 1/4. Okay, so I'm going to put it over here to say that x is 4 divided by 4, right? Which is just like saying 1. And that is equal to 16 on 1 divided by 4. So that's 16 by 4 like that. So what does that mean? Now, what does that mean? So let's just focus in on that bottom bit, that's 16 to the power of 1 divided by 4. And so what we're asking is what number times itself 4 times is equal to that? So what number, like maybe 2 times by 2 times by 2 times by 2, right? 2 times by 2 is 4, 4 times by 2 is 8, 8 times by 2 is 16. That's our number, okay? So that's what it's saying here. The final equation here is that x is equal to 1 over 2. Okay, and so that's our final solution. So hopefully that makes sense. It's a little bit tricky, this equation. It's with a non-calc, but we're about to go into a more tricky question. Okay, so this one here is asking us to simplify for part D all of this. So that's pretty intense, right? Let's go ahead and try to simplify it. So we're going to use a couple of log laws. Now, some of the log laws that you're going to be interested in is that if you have the same base, which everything does here, if you notice everything is to the base of a, and if you plus things outside, right? So if you plus things outside, that becomes a times inside, right? So that becomes a log base a b times c. Now, if you minus, then it becomes a divide. Okay, so for the inside stuff, that becomes b divided by c. So let's do a couple of examples here. So first of all, let's focus on this log a3 plus log a9. So that just becomes, using the first thing, just this value here, log a, now 3 times by 9. All right, and then times by log a 5 to the power of 2. Now let's do the bottom bit. Let's simplify that, and that'll be 3 log a 25. All right, and then that's times by log a, and then 3 divided by 1 is just going to be equal to 3. Okay, so that's the first bit here. The next bit is that we can have log a turning 5 kind of reminds me of something else. And I'll write it out. I'm going to move everything to make it easier. So log a, and then 27 here, I'm going to write as 3 to the power of 3, which I think might come in handy later. But 27 is 3 times 3 times 3, so I'm going to leave it like that for now. And I'm also going to write just the 5 squared, okay? And if we all divide by that, now I'm just going to move things over to make this easier. And we've got a 3 out the front, and then we times by this log a 25. Now there's 2 ways to do this. I can either scratch this one and say that that is equal to 25, and then see how it's 1 divided by the same thing. So I can cancel both of them out. Or what I can do is I can make this one 5 squared, and then I can cancel them out. So it's all up to you. Now there's one more rule that we've got to go through, and that is that if you have a power, right, that you can write out the front. Okay, so that can be moved out the front. So we can see that happening, right, with that 3 and that 3 there. So we'll get onto that in a second. But what we can say here is that log a of 3 and log a of 3. So let's say I have a 3 at the front and a 3 here. I can scratch that 3 and put it out the front, and therefore I can cancel those ones out. And then I can get 3 divided by 3. Okay? Or what I can do is I can put that 3, instead of being there, I can put that 3 at the top and then cancel everything out and say that's equal to 1. Okay? And so that is our final solution here, is that it's just all equal to 1. Pretty complicated, I know, but you have to use all of your log laws. Heaps of questions like this exist on my website. It's in the link below. If you have any questions, reach out. Would love to hear from you. Like the video if it's something that helped you, and share with friends as well.